Do you have the audio set up? You should be good if you can test it, preview it, see if you can hear Hossein. You should. So preview it. Make sure you hear him from the preview. Oh, you can't preview. You can't preview. Let me preview. Okay. Yes, we're ready.
Okay, we're live.
Okay. I'll also monitor us from YouTube.
Yeah.
So
can you just test the YouTube audio real quick?
Yes. Back from YouTube, so we're good.
Okay.
All right. Let me go to the Hangout. Sorry, to the video, and start introducing Hossein. All right, here we go. All right. Hi, everyone. This is Asan. I'm hosting you for our next Lunch and Learn for the MLOps workshop. Basically, I think they got two of me now. Although your camera is much better. So you're with me with Hossein Sarshar from Microsoft. We're gonna go through give you more context about the MLOps workshop that's coming up. We'll try our best to also answer questions. So the presentation is about half an hour, 40 minutes. But feel free to jump in if there are any burning questions, clarification questions. In general, I'll try to monitor it so that Hossein gets to the most important parts of what he wants to get through. And after that, it'll be a little more free up until 1 for you to, more of a free form for you to ask more questions if you have. Okay, 1 second. All right, so let me introduce Hossein. I'm pleased to introduce Hossein Sarshar. He's a senior data scientist at Microsoft, which helps Microsoft enterprise customers solve their data science problems on Microsoft Azure. Prior to this 5-year data science career, he was a software engineer at almost a decade. Hossein holds a bachelor's and a master's degree in computer science with focus on parallel and distributed computing and machine learning, respectively. All right, beautiful. With that said, please, Hossein, take it away.
Awesome. Hi, everyone. It's definitely a pleasure to speak at this Lunch and Learn series. Today, we're going to focus on MLOps, and we're going to give you very high-level overview on what MLOps means, like a MLOps 101. And then at the end, we're going to discuss what we're going to cover in the workshop. So that will be, I hope that's an interactive session. So please just send us the questions if you have, and then I try to answer them as we get them through.
On YouTube and Facebook.
Yeah, YouTube and Facebook, please. Awesome. So this MLOps conversation is very close to my heart because it's super dear to my heart, because we also had another DevOps for data science session. I think it was early 2018 or late 2017. The title was DevOps for Data Science. So that title, it was quite like, I mean, very popular at that time. But then over time, it get into AIOps, and now in 2019, we're actually talking about that with the MLOps. But all of them are actually the same concept, which we want to focus on, how we want to actually operationalize our machine learning models and follow good practice for our machine learning lifecycle. So if we want to describe or explain what MLOps means, actually a set of tools, processes, and mindsets that aim to make machine learning lifecycle reproducible, trackable, testable, and maintainable. So that's actually, sometimes you think about MLOps as a technology or an algorithm, but that's not really the case. And the MLOps is basically a philosophy, a mindset, which actually, because of the importance of machine learning, became very pressing. And because of that, There are a bunch of tools, a bunch of technologies have been built around, a bunch of processes have been built around that, which by leveraging all of those, you can come up with your own methodology to basically follow. So that's basically a framework which you can pick and choose everything which is within it, and then come up with your own custom basically methodology or method for your own organization or your own workflow. But before we get into the MLOp itself, I just want to emphasize on the importance of the MLOps. Machine learning actually automates decision making. Also, I had that slide 2 years ago in that DevOps for Data Science workshop, which I think it emphasizes a lot on why machine learning is really important. We have to take it super seriously when it's in production. So machine learning actually automates decision making, right? So if you have a robo-advisor, for instance, if you have your money there, it basically tries to buy and sell the stocks, right? Or if you want to go to doctor, you see some assistant devices that basically, in medical imaging problems, they actually want to find a particular kind of disease from the picture or from some kind of sensor data they're getting into that. So they want to basically automate some sort of decision making on the physician side, or maybe help them to basically provide some more insights. Or even when you get to stores and retail stores, there's so many of them basically are leveraging machine learning to come up with elastic pricing and dynamic pricing to basically come up with the best price of a particular good today or tomorrow. And based on that, they will basically run that on a scale. So imagine if that goes wrong, what will be the consequences? We also have, that's actually not something everyone is scared. That actually happened in the past. In 2019, Knight Capital actually lost about $465 million for lack of a proper life cycle for their automated code generator. So I just copied that from the court reports, where it's really interesting story. It's definitely not very interesting from those who actually made that mistake. But overnight, during weekend, there was a test team in 2015 actually used the test data to run a disaster recovery test. But when they moved that automated code generator into production, they forgot to change the path to the test data to the live data. So because of that simple mistake, they lost $7.5 million in just a few minutes by just generating wrong codes, basically based on the test data, which was completely wrong. And if you add all of those, all of the losses that they had within that report, you get to $465 million in just 45 minutes. So it is a pretty long report. If you're interested to read, that's the link to that report. And also that was cited in another NIPS paper, which focuses on ML in production, which they added that all, and then they found how much they lost in total. So that lack of test can have very, very significant losses and problem, can make a lot of problems for anyone who's actually leveraging technology and machine learning. And definitely that's different from context to context. There's some of the contexts are super, super sensitive. Some of them are not that sensitive. So that's not the end of the world. If you just, recommend a little bit wrong song to your Spotify players, but that becomes very sensitive if it is a sensitive domain, of course, such as this one. But why MLOps is hard? We have done studies over the past couple of years, and there were a couple of studies came up to the conclusion that about 8% of machine learning initiatives actually go live and they're successful in the production environment. And about 80% of the times out of those, the failure is due to a wrong ML lifecycle or the lack of machine learning lifecycle, proper machine learning lifecycle. But why it is that hard to the extent that many companies fail at it? The reason is because In traditional software engineering, you basically have your code base, your development environment. You sometimes have a release environment in the middle, and then you have the running system, basically, where you have your actual customers or user actually interacting with that application. So whenever you make the code, you would just, integrate it with your running system. There are three major tests. You can increase that a little bit, but there are three major tests that you need to think about. The unit test, which focuses on the features you have developed in the code, so just make sure the features you develop doesn't fail. The integration test, which focuses on when you write the code and push it into production, that integrates well in the running environment. And finally is the system monitoring, where it focuses on how the application is basically running in the wild world, and if it is failing, if like latency is dropped or something like that. But when you get to the machine learning context, it becomes super wild west somehow. You have a lot of assets to control and monitor. Data gets in. Data itself is super complicated. We can have, there's so many scenarios that data can go wrong. The new data comes in, the data structure changes over time, the skewness of the data, the distribution changes. At the model itself, the ML code actually can become super complicated. You have a code for training, you have a code for inference. That code generates model. You have a bunch of tests only for the model itself, from the accuracy perspective and also for the KPI perspective, for the performance care perspective, so many of that. And then finally, when you push it into production, you have prediction monitoring, you have a lot of tests there, A/B testing, other stuff. You want to make sure that the model is actually working well in the live. And then in addition to all of those, you still have your software engineering tests, unit tests, integration tests, and system monitor tests. So that's the reason so many people try to ignore that and basically say, that's super costly, basically, if you want to approach this and you want to have a proper ML life cycle. And some folks really fail somehow to accomplish that because of the complexity you can see when it is like simple diagram. When we think about ML life cycle, we mostly, focus a lot as ML practitioner and data scientist on the training part. A little bit of us focus also on the data preparation. We also want to own that part. So some of the data science team want to even see how the raw data is generated to the curate data. So they want to even own that piece somehow, at least fully understand that part. But few teams actually focuses on deployment. And some teams actually, want to even see it only unidirectional data preparation, model training, and deployment. There's just few teams actually want to connect that deployment back to the preparation, to think of it as a loop, because they just we personally love to have trained it, because training time and model building is actually quite fun. But when you put it into production, so many things can happen there, and try to just turn it off and completely ignore about what's happening in the wild. But in the best case scenario, this is what we mostly think about. We think like all of them have like equally important and like equally basically complex in terms of the system's complexity. But the reality is very different. So this little square here is basically the amount of ML code which was required in the entire ML system. That's actually a study done by Google in 2015. That's a NIPS paper. It's interesting to read if you're interested about that. Go ahead and read that for sure. But they actually studied the amount of code that they needed for different parts of the ML system, and actually quantified the amount of work and complexity which is required to have all of those environments and all of those pieces and assets up and running at the same time. It is interesting that was 2015. So 2015, many of the ML were, you had to use very low-level libraries. There were not a lot of like high-level and pretty abstracted libraries that we have now. I imagine if you run the same analysis again, you would get even a tinier square here, basically. So that becomes even smaller, and the rest become even more complicated. There's some good news here. Some of the complexities are now getting also more abstracted, like the email on the serving side, and things are getting simpler. But still, the picture still holds true. So the complexity is still here, and it's sometimes completely overlooked. And the reason it's overlooked is sometimes when you have a very big problem or a very small problem, you tend to ignore that. And this is a very big problem, actually, I believe, that many teams actually ignore that. So we think that once the model is built, we're happy, we can just push it there and we're done, we can go home. But that's not really the reality, as we can see here. All right, now I want to focus on what are important in the ML life cycle that is actually missed, and how we actually want to add on top of that and build on top of that to build a complete system and hopefully like have a full proper ML life cycle, basically. An app dev workflow is now these days pretty mature. I mean, most of the teams, even very trivial teams, still follow some of the practices where make them quite ahead compared to most of the data science teams because of some of the standards they follow. So in particular, most of the software engineering app dev teams leverage a source controller such as GitHub or Azure DevOps, or so many GitLab and so many other Git-based source controllers. And then once they push or commit push their code into the source controller, there's a CI/CD pipeline. I will get to that later on in this session. But think of it as a bunch of tests before you push it actually in the deployment environment. So whenever a code is actually changed, there's so many tests happen on fly, and then that changes will be pushed into deployment and then become available to the end users. But when you go back to the ML workflow in a data scientist or ML practitioner, that's a whole different world. So we tend to use our Jupyter notebooks or some sort of IDEs to basically write our code. Hopefully it is in Python, it is not in MATLAB. So we actually write our code, mostly scikit-learn, where we do some bunch of tests to build and train the model. And then once we save the model, like a pickle file or some sort of model, we basically test in our own local computer, and then we're happy. We could recognize the cat in our CNN with 99% accuracy. So we get super excited, super happy. But things fall apart when we want to work within the broader workflow of an app dev and ML practitioner working together actually in a broader system. So where these fall apart, this particular workload that I just described. So one of the main problem with this approach is that the process is not reproducible. Well, let's say if you come back in about a year and just read your code, you basically most probably have forgotten how you actually got to that stage. What was the process? What was the different experiments you actually ran through to actually got to that stage? You completely forget what is the pre-processing steps, why you actually chose that particular end stage code, and then the parameters you have tested to build the models. What was the accuracy along the way? If you have worked on that modeling for about 2 months, what was the steps you used? What was the particular methods you used to get to that end stage? And that becomes really hard when you want to tweak that or change anything within the model. It basically seems like starting from scratch. Even worse than that, if you win lottery tomorrow and you want to go home and enjoy your rest of life in retirement, is actually, is a substitute of hitting by bus. So if you win a lottery and you want to go home, the next data scientist basically become completely hard for them to follow what has happened. Just by one snapshot of that Jupyter notebook, it's super hard to understand what's going on. Even worse than that, the model itself, if you only have the model itself and no code behind that, is become a bigger nightmare.
Yeah, don't do that.
Don't do that, yeah. Which unfortunately that happens most of the times, yeah. I've been working with a number of industries now, and that's something that happens most of the times. And that's actually our natural lecture path, right, progression, because we want to focus on that easier first. We are running, the time runs so fast, so I'm gonna go a little bit faster. So when you focus on experiment reproducibility, which is the focus of the first day session, we think of that as a data and ML code which get married together to actually produce the model itself. There's some feature engineering required here, some hyperparameter tuning is required here to actually have a cycle of that. So these are the things which are always changing, and we have to have a system to basically track that. When you also add the compute also, that becomes another complexity where we actually train the model. What was the requirements? What was the drivers or libraries that are required to be installed in that compute also adds to that complexity. So the remedy to that is basically to version the code in a proper way, having a right CI/CD basically pipeline for the code and have the pull request and etc., which will be focused a lot more in the session. Having versioning the data, that's also very, very important these days because we want to see exactly when you got to that 99% accuracy for that cat, what data you actually use to do that. So I want to reproduce the whole thing again. What metrics and parameters I use, I want to also be able to track and monitor and version all of those. And finally, I want to also version the environment configuration, whether I ran it on my Android phone or I ran it on a 10-node GPU cluster. These two have significant differences, right? So that will give you the full experiment reproducibility. So I can reproduce the experiment. If I have all of these, I can, if I track completely, follow the good practices, I basically can reproduce that. But then we get to now I have a reproducible model. Now what? I have the model in my hand. Now what can I do with it? So it becomes quite a little bit complicated when we actually want to merge the data science workflow with the app dev workflow. Imagine if you're building a model as part of a bigger application, or even if it is a standalone, they want to merge it to an operations team and pass it to an operations team, cloud ops team, for instance, to basically push it into production. So what mostly happens is that mostly we package it, zip it, and then email it to the app dev. So the app dev basically receives a file, and that's very scary for them. And they say, I want a model repository now. So, so the next step is basically to think about model management. Imagine you have ran your experiment and produced 200 models, every time gets better. We actually have to have an ability to version and keep all of those models so that we can see the lineage and the history of the data, the experiments, the compute, and the model which was generated. And then the model needs an environment to actually run. So we need to containerize and Dockerize, we can use interchangeably, of the model in an image so that we can pass it and make it usable by anyone, an app dev and a cloud ops team for anyone, and then just make it available basically for some to basically pick it and deploy it. All right, so when I here refer to triggering an event, I'm actually referring to an environment. Basically, when you push something, I'm able to trigger an event, and based on that, I can do something. But in order to explain why that is important, I need to explain the CI/CD pipeline very, very, a high level for sure. So in CI/CD, or continuous integration and continuous development, continuous deployment or delivery, these two have the slight differences, but we can use it interchangeably. So continuous integration and continuous deployments. When you think about that, in continuous integration, we think about having your code needs to actually be branched out. So whenever you're working on a code, whenever you're adding a new feature or making any modification or optimization, you need to create a feature branch from the development branch. And then once you're done, you need to merge it back to the development branch. And that merge is actually happens by automated tests. So whenever you want to merge back, you want to make sure nothing within your code actually is destroying anything in the development branch, main branch. So there are a couple of tests needs to be developed there. So all of these actually are some sort of merges here, which is happening, which the important part here is the automated tests. So you need to have some automated tests for every single feature or every single improvement you have. You have some server to basically run the tests. And also, you want to be able to merge as often as possible to the development branch. Therefore, you have the most updated one, at least by the end of the day. For some machine learning problems, it's going to be a little longer, but it needs to be merged back at least once a week. But the test is very important. So you want to branch it out and make your modification and then merge it back to the main branch. When you get to the other part, which is the continuous deployment. So whenever you merge back to the development environment, that development environment actually has the newest features and the most newest feature. It's different from the one which is in the development environment, deployment environment, or the master branch, basically. So then the other aspect becomes in place. So your continuous integration focuses on development and testing, and then pushing that into deployment actually happens on the continuous deployment part, where automatically things will be pushed to the user and end user. So you want to have a model management server and system to basically being able to have that continuous deployment on your models. Is there any question or good?
We got around 5 to 10 minutes at most.
Perfect. So now when you think about bring it from software development context to model management and model development, it looks like this, where you basically have a model store here where your data scientists can push their newer models into that with full lineage. And then the app dev or cloud ops or anyone else can basically use that and picks the most recent model and puts it into basically their deployment environment and basically use that model for itself. And the other piece which is important is once a new model is added, that needs to be added as part of the DevOps pipeline, or again, that's CI/CD, right? So we want to basically be able to have all of those tests, which happens when you merge a new thing into the repository to just make sure the new model is actually working as expected. And there are a bunch of tests we can run, and that's actually the focus of the second day of the workshop, that how we can actually validate the model is working well, the integration is perfect, and then we are basically in a safer spot, and that needs to be done actually automatically. And now we get to the basically last part, if you like, which is the model deployment. So model deployment, it becomes pretty much more complicated than the model management and the experimentation and reproducibility, because there's so many ways to basically deploy the model. If it is batch or online, these two have very different considerations. If it is on cloud, on-prem, your local computer, your local cluster, on your company or somewhere, or it is on the edge, it is on the Raspberry Pi for an ARM device, right? These are very, very different environments and has very different consideration you need to think about. You need to leverage the somehow containerization and Dockerizing basically your models into images to make it shippable. And I will explain a little bit like what that means if you have time. And then choosing container orchestrators basically to orchestrate those containers. And also that's the other part which we will touch slightly at the end of this session if you have time. And so once we decide all of those and the model becomes shippable and we choose the deployment environment, we want to actually make sure that the model performance still is on par to what we were expecting. There are a couple of things that can go wrong. The data can drift, like the distribution of data, which we use at the test time and train time, is different at the deployment time. So that has to be monitored and checked continuously. The model interpretability can also become a part of the performance because we want to understand how every data point is actually scored, and that becomes a part of the performance metric and the model monitoring basically piece. Computational time, like or latency, how much time does it take to basically run or train or to deploy the model? And finally, model decay. Like if you see that the model is basically losing its quality and it just reducing his performance, we need to have some bunch of still acquire some labeled data, which is unseen, of course, to basically test the model from the accuracy metric and perspective over time, where it is in the wild. In addition to that, we need to basically think about system health, security checks, and etc. And all of these should basically work as part of a feedback loop. So So then the model, once the model is deployed into production, then at there, you will basically get the feedbacks back to the model store, and using that, you can think of it passing to the data scientist to basically improve or retrain, or using an auto ML technique to basically retrain the model itself. And exactly described here, that's part of the ML loop that is important to be in place to basically connect that model in wild and bring it back to production. So this plot is basically what we want to accomplish in the third day. So the A/B test, I'm not still sure that we can accomplish it because it's a little bit complicated compared to the rest of it. Hopefully we can achieve that, but the rest of the ecosystem is basically what we want to build at the end of the day through a scenario that we want to follow through the workshop.
Okay. Do you mind if we stop here? I get some sort of logistics
Sure.
slipped in, and then we can open it up a little bit to questions.
Absolutely.
And then if there were, if we run out of questions, we can get back to add more content. Is that good?
Beautiful. Yeah.
All right.
We're almost done. Actually, it's a good place to.
Oh, really?
I just want to see this, show this, and then
Okay.
I do have some follow-up contents.
Beautiful. Always planned. Always planned. Okay. Let me turn on my camera. Not to disturb the audience with this voice coming out of nowhere. All right. Okay. All right. So for those of you who have actually joined the workshop and showed interest, we are happy to announce that we have a special discount code that I just sort of added to the chat. Here's just the discount code. You can use it and get a much better price for the workshop per se. Do you mind turning that on?
Oh yeah, sure. I'll do this.
Thanks very much. So I'd like to. So the workshop is, as usual, going to be in 3 sessions. It's both online and both in person. Where Hossein is going to go into the depth of it and the hands-on section implementation as well, which I would definitely enjoy. And during these 3 sessions, hopefully, he'll bring you sort of from the MLOps scratch to the up to speed with all the way to deployment. Feel free to ask any questions. Let's spend around 5 to 10 minutes. If there aren't more questions, we'll get back to him. We'll have a little bit more content until we close the session at around 10 to 1. We're monitoring both Facebook and YouTube, so if you have any questions, just write it down. If you want to know if it's a right fit for you, if you have any questions with regard to that, basically, if you think you know everything that's said over here in depth and detail, maybe okay, it's not for you. If you think you've never coded in Python, it's probably not for you. So Hossein's going to go a little bit more detail in saying that. But you don't have to know MLOps in order to take the workshop. Actually, that's the point of it. Would you mind offering a bit more insight?
Yeah, sure.
That? Yeah,
absolutely. So we're targeting this workshop is like an intermediate kind of workshop for those who have done some work in machine learning and who are seeking a career in basically getting into the industry. If you've done some Python work, if you've built some model by yourself, and in particular, if this is an important topic and is completely, and you have some problems with that in your day-to-day work, is definitely targeted completely towards you. In addition, if you're thinking to get into the industry, as I said, that's a very valuable skill set, which is now it has become very much more important than it was before because of the content that I just provided. That's also something helpful. Knowing a little bit about cloud, that's also another part, which I think another familiarity to clouds is also can be very helpful in terms of the first day. You will have a much faster start. But it doesn't mean that if you're not familiar with cloud, it's not a no, but it will be very helpful if you know. So if you do not have that familiarity, getting that is not really hard. So, I mean, I would say spend some time to go over the cloud of choice. If you want to focus primarily on Azure, but also we're going to cover cloud, Google Cloud, and also AWS as part of the content. So if you want to get familiar with Azure, I would highly recommend you get there and just start playing around with Azure. Just apply for the free credits. You can get also that from all of the other cloud providers, and please bring that subscription yourself to the class. That's also another important thing. I just wanted to mention that please apply to that free credit and bring that to the workshop. Most of the tutorials you will good with that free credits, but a small portion you still need a paid version, so you can always upgrade to the pay as you go, and that's max of, in worst case, $50. It won't go above that. But again, that's optional. We can skip those parts and still stick to the, or somehow find a workaround that basically to stick to the free credits.
Yeah, if you can't do that, please do so, because you're gonna get a lot more from the workshop if you don't have to worry about the resources that you're using. All right, so I think I had a question. I'm hearing TF is more prominent in production. Is there a good solution for PyTorch?
So we want to think about the production environment from a technology agnostic, basically. So because of that, we don't focus on a particular like PyTorch versus TF or scikit-learn. I'm going to think about what are the remedies for most of the basically frameworks which are available. So I would say we're gonna mostly think about that from agnostic perspective, not a particular piece of a particular framework, basically.
Mm-hmm.
Yeah.
But would you be? But that's a good question. So we kind of we don't want to advertise like one or the other, but they have ups and downs, right?
Yeah.
So TensorFlow was the earlier one.
TF serving is pretty good. Yeah,
pretty stable. PyTorch did not originally have an extensive sort of deployment services, but it does have some now, and it's very clear in documentation, and the language itself is very elegant. So I'm just stating the truth. I'm not really biased. In that sense. I know that you'd like to stay agnostic, but you think PyTorch would still, be competitive?
Yeah. So as you mentioned, recently they have released. They try to just add some deployment capability to the PyTorch, and but this particular workshop, we don't want to. Again, this is because we have only 9 hours to basically focus. There's so many contents here. The main context is that what is the flow that is important here? What is the right, proper machine learning life cycle that we need to follow?
Right.
And so if an XYZ package or technology comes in and they have some deployment capabilities, you can basically bring that in. So I don't want that become a blocker in that sense. So that's basically an open environment. So because when you like if there's any package which has some deployment capabilities native, or you can manufacture that, you can containerize it and deploy it somewhere, right, through a web service, basically. And it's not unique to TF, not unique to PyTorch, not unique to scikit-learn or any or Spark.
Yeah. Absolutely. So basically, you can. Short answer is as Hossein said, that's not like specifics of this framework or that framework is not the focus of the workshop. But to answer your question, if it has deployment capability, which PyTorch does, as well as TensorFlow, you can integrate them.
Yeah, and also to follow up with that, we do have some tutorials. And also we have some homeworks. So for homeworks, you can pick the frameworks that you like, basically, to just orchestrate and build your own pipeline.
Yeah, that's beautiful. We have another relevant, actually, question. Case in point, is the workshop going to be more focused on the technology side of MLOps or the process mindset?
It's going to be both.
Both.
Yeah.
Okay. Yeah, absolutely, really. So both the mindset and both the technology.
Exactly. We want to have a full ML pipeline in production by the third day.
Okay.
Yeah, which needs mindset, process, and technology, basically, all of them together.
So I want to emphasize this. It's super important because people go do all these. I don't think nowadays people have a lot of scikit-learn on their resumes, but they have all these frameworks on their resumes, and it doesn't, as someone who wants to hire a resource, that doesn't really finish. That doesn't really reach the purpose of the hiring. I do want to know if you can actually deploy a system. Like otherwise, otherwise it's like if you can't really integrate, if you can't really deploy, it's like I think it's an important, significant part of a data scientist's job to be able to know how it integrates. Now, in some of the teams that are very, very big and they want to maybe push state of the art, they may have so much of a specialized role where they say, okay, you focus on this framework, be it PyTorch, whatever, and just try to beat that score, right? Fair enough. But still, you're going to deliver that code. Someone else is going to read that code. Someone, evident if it's not yourself, which is more often than not you, is going to integrate that code. And you need to have that understanding at the very least, and being able to offer a hand in deployment.
Exactly. But that was actually a very good point, because you need to have some educated conversation with the ops team, right? So they need to know that, that conversation can be, I have no idea, they're going to turn it off, so it's all your responsibility, the ops team, to follow. Or that's a very mutual conversation, educated conversation from the ML practitioner, data scientists with the ops team to basically help them to have the best journey possible. And that makes a lot of problems also fade if that's actually happening.
Absolutely. Yeah. And DevOps team right now, I can say from looking at quite a few big organizations, they don't have MLOps per se. That's something that's being developed. So I would easily argue that you'll be very employable if you know how to do this. They look at you to actually tell them how are you going to do these things, because they do not appreciate necessarily all the nuances that a stochastic machine learning model has that could be very different from a deterministic flow, if that makes sense.
Exactly. Yeah, and the test that will make the test very different from deterministic software.
Yeah. Exactly. Yeah, beautiful. If there are questions, feel free to ask. Oh, okay, there's a question. In your experience, what percentage of the industry in Canada is following MLOps, and what's the cost of not doing it right?
So there are not a lot of. So I would say there's a big mix of different levels within the organizations. Even within like tech companies like Microsoft or Google or Facebook, not every team is the same. The quality that, for instance, the Bing team or the Teams team have is very different from another team can be. So similarly to an organization in Canada, there's some teams who actually are quite advanced and some teams do not. But from organization perspective, I would say their Canadian companies are actually going towards that. That's become something very important. Like 2 years ago, it was more aspirational. They were just experimental. Yeah. But now they want to get some ROIs out of all of those investments they had in the past 2 years.
Yes.
So they now want to push into production. They have some efforts that mostly fail. Yeah. So now they want to have a successful deployment. So now this is becoming very important in the next couple of years, for sure.
Yeah, I definitely agree. So we've had a quick question. Says, I am new here. Can anyone tell me, is it a course? What exactly the instructions are concentrating on? So for those of you who are new, this is an intro session to the workshop that's coming on, run by Aggregate Intellect. We will share the link in chat if you'd like to know. Hossein is going to teach this workshop, senior data scientist from Microsoft. It's on MLOps. And this video will be also available if you want to, not live version of it. If you want to go back and see what was discussed. The workshop runs in 3 sessions. For those of you who are here in the chat right now, I left you a little bit a discount code for joining the session. You can use it and purchase the workshop at a discount. It's a 3-session one. Each session is about 2.5 hours, 3 hours. A mixture of it's often a mixture of theories and hands-on. So hopefully by the end of the workshop, you'll be able to deploy ML systems.
Yeah, it's like 50% theory, 50% hands-on. And within hands-on, again, we will have some added theories added.
Yeah, so feel free to ask other questions. Let's do a little bit. Let's go on with the content for a couple of minutes. And then.
So whatever we discussed here up to now is actually for only one model. So this is only for one model. Let's say there are hundreds of teams within your organization are building machine learning models, and that becomes a model hell, basically. So that's really hard to manage it without having a proper life cycle. Even some problems basically still require you to deploy so many models. Imagine if you're building energy forecasting, for instance, for stores. If you have 2,000 stores, then most probably you need to deploy 2,000 models at least to basically for each model, for each store to basically to predict the energy forecast for that particular store, because the data can be very different, etc. So within those situations and scenarios, the ML lifecycle becomes even more important. So in order to appreciate that and see what's happening actually behind the scene, we will focus on Dockers and containers. That's also part of the content we're going to cover in the second day, and also the third day a little bit more. So we're going to focus on why containers are important, why Docker is important. So previously, when you wanted to deploy an application or wanted to build an application, you would have a server, sometimes real hardware, sometimes a VM, basically where you had to have a bunch of application software installed on that server. So you had everything you wanted to install, and a year from now, you would completely forget what you had installed. So you had basically, you would use virtual machines basically to make it a little bit more abstract. Instead of a single big hardware, you would leverage some kind of virtual machine, so you would virtualize your hardware. But again, that virtualization brought so many challenges. So in this picture, you will see the infrastructure like the hardware. Some cases you would have a host OS. In this case, it doesn't have it, and then you will have a hypervisor, like a kind of virtualizer somehow, like a VMware or Hyper-V, something like that. And on top of that, you will have the virtual machines. So virtual machines comes in with the entire operating system stack, from the operating system software, all of the applications which are necessary to make that operating system unique, and also your application on top of that, basically. So if you wanted to have like 3 Linux VMs, you had to basically have 3 of these VMs, which all of them share the same operating system, and many of the applications were the same. So another movement actually happened to make it simpler and much more abstract and agile, and that was through Dockers and containerization, basically. So Docker is one of the containerizers, but there are some others, but this is very, very prominent. In the Docker sense, you have the host operating system, which has the common kernel for the operating system. You don't have to copy the operating system kernel over, but you can only have the application and everything which is required for that application to actually be self-contained. So in other words, you would create or Dockerize or containerize your application on Linux. So it doesn't need to copy the Linux code on it, but the rest, all of the drivers you need to install in the operating system, all of the packages you need to install, all of the runtime you need to install, the instructions are there within the Docker, and then that image becomes shippable, basically. And in terms of complexity compared to the VM, it shrank the size from a couple of gigabytes to a couple of hundreds of megabytes. So that was a huge improvement in that sense. So when you think of it from the ML perspective, each of these applications can actually become a containerized application or a containerized model. So there's also a Docker hub where you can basically find any images of containerized basically runtimes. So like TensorFlow, there's so many flavors of TensorFlow for Spark. There's so many flavors of Spark with PyTorch. You can find them, and then basically we can download them and we can run it on your local computer. You do not have to like install packages by package and libraries by libraries, and you will become a very complicated. Basically, that makes it much simpler and much more abstract. So when you think of it, when you think about that abstraction, that actually can help a lot in your model management. Imagine you have three models now that they interact with each other. Model 1 is SparkML, does the spam detector. Model 2 is the TensorFlow model, which does the OCR. And Model 3 is a PyTorch, which is like using sentiment analyzer. So these two will need to send their results to the basic spam detector. OCR converts the image into text, send it to the spam detector, and the sentiment analyzer sends a score to the spam detector basically for the first model to understand and being able to predict whether that's a spam or not. So previously, you need to have all of these models into one single computer, and all of the dependencies can potentially become pretty complicated when we'll overlap and some conflict with each other. But then with containerization concept, we can basically use one node, which is like potentially GPU enabled, to host the Model 2 and Model 3, which will potentially be leveraging some sort of GPUs, and the other model, which is going to be a SparkML, which would potentially leverage only CPU on another computer, basically, and they interact with each other. So you can simply Dockerize that and ship it. So later on, if you feel there is a potential scale problem, then you can scale it up. You can basically copy that. You can basically instantiate containers from that image and then create more basically containers from for instance, the container that runs Model 2, and you can scale it up. So you can use that Docker, just pure Docker, to basically leverage that. But then it becomes super complicated when you have thousands of models, and the environment can become very complicated, and there can be so many options for hardware of choice. Then you require to have a kind of orchestrator for all of these containers. So then you'll get to Kubernetes, which is one of the, industry standard for container orchestration. And then within that, it will be able to build clusters, basically, and then make it like load balancer, add load balancer to that, make it scalable and auto-scalable. Some of the, also some of the other functionalities, abstraction of your infrastructure layer to a huge extent, and make your deployment environment actually quite seamless and quite resilient. And from that, it also adds a lot of simple APIs and simpler APIs to manage that environment, and makes those complex model environments and a simple, much simpler abstraction basically provided that for you. So that's also the topic we're going to target on the second and the last day basically of the workshop. And yeah, so I can stop here. I think we have only 2 minutes left.
We have 2 minutes left. I want to give a last chance to people if you have any questions, quick ones that I can address. There are challenges, and I would love to hear it, but we're out of time. Join the workshop to hear about the challenges. Let me give you a few seconds to see if you have any questions. Meanwhile, the ticket discount, the discounted tickets have been, the link of it has been added to the video description, and for people on YouTube, feel free to use it. Again, we don't have many tickets left, and only very few, and we're almost at the cap. So if you want to get it earlier, you can participate in the workshop online from anywhere in the world, or if you're here in Toronto, just drop by in person, and we would love to have you. Once again, this is the MLOps workshop run by Aggregate Intellect. This workshop will help you take your machine learning models and actually deploy them. It gives you all the necessary concepts and the tools, hands-on and theory, to be able to deploy such systems. All right, we're at 1. I don't see any other questions. If you want to have any final remarks.
Cool. Thanks a lot for your time, and look forward to seeing you at the workshop.
All right. See everyone soon. Take care. See you next time.